If you subscribe to the channel, you'll get lots of interesting videos like this one. And if you like the video, it'll really help us out. Please comment down below for any other interesting things. That also really helps us out as well. Hi, and welcome to another edition of AZ Theory. So let's go through an example of converting a grammar into Chomsky Normal Form. So this was a really simple way of representing any possible context-free grammar. And what are the rules? Remember, they are the only variable that can make empty string is the start one. You can have a variable go to a single terminal, or you can have a variable go to two variables where they're not, neither of the ones on the right side are the start variable. The one on the left can be, but not the ones on the right. And we went through 5 steps that had to be done in a certain order, and I encourage you to figure out why they have to be done in that order. And if you did them in a different order, does it actually still work, or can you find a counterexample where it doesn't work? So let's here do an example. So this grammar I'm gonna make up on the spot. I don't have anything in front of me. I'm doing this completely live, quote unquote. So let's make up a grammar. So let's have the start variable be s, just for kicks. And we're gonna have, let's say, a, big B, or little b. So capitals are variables, lowercase are terminals. So then let's say I have a go to s, or empty, or ab. And then b makes b, or let's see, ASA. Okay, so this is sufficiently complicated, and I should indicate that S is the start one. And so this is sufficiently complicated, and it's definitely going to need all 5 applications of the rules, and not the rules, the steps, to be able to convert it into Chomsky Normal Form. So we can see that the start variable is on the right-hand side of a rule. There's a unit rule right here. There's a variable that goes to epsilon, and it's not the start variable. So there's a lot of things we need to fix, and long right-hand sides and all that stuff. So the first step, remember, is to ensure start variable not on right-hand side. Okay, so make sure that the start variable is not on the right-hand side. So what I'm actually going to do here, and what I'm going to do for the rest of the steps, is I'm just going to copy down the grammar that I have, and I'm going to make any adjustments as needed. So, and actually I'm going to do it in the color that the step is going to correspond to, so I'm going to change the color throughout. So red is the original grammar. So what are we going to do here? Well, the step says to have a new start variable called s0 go to s, which is the original start variable. And we know that this works, and it doesn't change the language of the grammar, because in any derivation of the original grammar, we can just append onto it s0 goes to s at the beginning, and that gives us a derivation in the new grammar. And that was pretty easy. All right, so let's do step 2. And that was to quote unquote eliminate so-called unit rules. And remember that not unit rules, sorry, I have it backwards, is eliminate epsilon rules. Okay, so those are the ones where a variable that is not the start variable goes to empty. And remember, we had that condition of whether a variable is nullable, which means either it makes epsilon directly, or through some combination of a bunch of variables on the right-hand side, all of those are nullable too, and then we can infer that the one on the left is also nullable. So again, I'm going to copy down this grammar right here. So paste. So I'm going to move it over to the left here, and I'm going to have a nullable variables list. So the first thing we should do is to go through the grammar and identify the variables that can make epsilon directly. Well, the only one in that case is a, obviously. B doesn't make it directly, S doesn't make it directly, S0 doesn't make it directly. So A is definitely on that list. But now we got to go through the rest of the grammar and see if any of the other variables can be made nullable. So if we look at B right here, this rule doesn't have any variables at all. This one has two occurrences of A in it, but it has this S right here, so we can't immediately say that it is nullable. If we find out later that S is nullable, then we can say B is nullable, but we don't know if S is. So let's look at S. Well, S goes to, so this variable, this rule doesn't help. This one doesn't help either because, well, we know A is nullable from over here, but the terminal here kind of mucks things up because we can't get rid of a terminal. So S is actually, we haven't found it to be nullable or not. And S0 is not nullable, or we can't immediately say that it's nullable because S is, we haven't found it to be nullable yet. So we actually just went through all of the other rules and found no new nullable variables. And so this is a complete list now. So B is not nullable, S is not nullable, S0 is not nullable. The only one that's nullable is A. So now what we need to do is to go through all of the rules in the grammar and add additional rules as needed in order to take advantage of when A can go to empty. So this rule doesn't have the variable A in it. This one doesn't have the variable A in it. This one does, has one occurrence of A. So what we're going to do is we're going to add one more rule in which that A goes to epsilon. Not where A goes to epsilon, replacing it with epsilon. We're simulating that rule with A goes to epsilon with another rule, which is this green one here. Okay, what about this one right here? Well, A goes to S, that doesn't have an A in it. Epsilon doesn't have an A in it, and we will get rid of this eventually, just not now. This one does have an A in it and has one occurrence, so we're going to do almost the same thing and add a rule where the A is dropped out. When I teach this, I call it dropping out. So when the A drops out. But now we get to this one, which is kind of interesting. So this one doesn't have A's in it, so we leave it alone. This one has two occurrences of A in it. So it's either the case that one of them drops out, either one of the two A's, or both of them drop out, which is entirely possible. So here, I'm going to actually be adding multiple rules. In fact, 3 more. The one where the second A drops out, one where the first A drops out, and one where both of the A's drop out, because both of them could have gone to empty. So we're simulating them with additional rules. And finally, once we do that, we handled all possible rules, so we got to get rid of this rule where A goes to empty. So what I'm going to do is I'm going to tidy this up a little bit, move these over. Cool, so that was step 2. Let's do step 3, which is to, quote unquote, eliminate what are called unit roles. So unit roles are the ones where one variable goes to one variable and nothing else. So just like before, I'm going to copy down our little grammar right here. I feel like Bob Ross of context-free grammars. So let's see, I'm going to put it over here. And this one's in purple. So what we're going to do, as before, is we're going to make a graph, a directed graph, where the vertices are the variables, and we're going to make a directed edge from one to the other if there's a unit rule of that form. So since there are 4 variables, I'm going to make 4 nodes, S0, S, A, and B. Well, S0 goes to S as a rule, so I'm going to make that edge in there. S doesn't have a unit rule, so there's nothing coming out of S here. A goes to S, and actually A goes to B also. So A is going to go to S, A is going to go to B, and the only other unit rule is B goes to S, so I'm going to have this arrow also. Okay, so how are we going to handle this? Well, we're going to look at all pairs in this graph and see, is there a path from one to the other? If there is, then what we're going to do is we're going to add additional rules. Okay, so let's see. Well, S0 goes to S, that's obviously a rule. So what we're going to do is we're going to take the rules that correspond to S and move them up here. So here, what I usually do when I'm teaching this to make this easier is I actually copy rules around. So the S variable has no unit rules attached to it. So in fact, what I'm going to do is I'm going to copy all of its rules. Just copy these 3 rules upstairs like this. Okay, so we handled that one. S0 can't reach A, so we don't have anything to do there. S0 can't reach B in any way in this graph, which is good. And the only way we could have gone to B is if we want to A, because that's the only thing that goes into B. S can't go anywhere, so that's great. A can go to S. So, and we can see that by this unit rule. So that means what we're going to do is we're going to, again, copy the rules of S down to here. So I'm going to have A, little a, big B, little b, little a, big B. This is going to be a little bit cramped. I'm going to make this graph a little smaller. Okay, so we handled A goes to S. A can't go to, it can go to S0. Okay, so what I'm actually going to do is we're going to copy these 4 rules down to here, but we actually already have, because A goes to S was already in there. So because A could have gone to S, we've already done this, so we would have duplicate rules, and we can always remove duplicate rules. They don't help us. Well, B also goes to S, and we can see by that unit rule here. So again, we're going to copy the rules around. The S rules down to the variable B. So I'm going to have capital A, big B, little b, little a, big B. Actually, what I'm going to do is I'm going to move this so it's not in the way. And I'm going to do it this way. Okay, so that it all fits on the same page. Okay, so that handles all of the unit roles, and the only thing, actually one thing we forgot was the A to B rule. I forgot about that one. So we actually need to copy the rules of B up to where A is. So that means we're going to have little b, little b, little b, ASA, AS, SA. Okay, so there are actually quite a few rules here. All right, so that's all that we actually need to do here. And as a final thing we need to do, we need to actually remove all of the unit rules because they're not going to actually help us. In fact, we have to get rid of them anyway. So I'm going to move these over so that it looks nicer. This S one goes away. And I'm going to move it in. And we don't have any other unit rules that I can see. Okay, so that's good. Now on to step 4, which is to have right-hand sides either being one terminal or just variables. Okay, so instead of having a mix of right-hand sides, we're going to have either one terminal or a bunch of variables and then get rid of the bunch of variables in the next step. So I'm going to copy this grammar down. I'm actually going to make it a little smaller so that it doesn't get ginormous. Yeah, I'm going to make it a little smaller. All right. So, and this was actually a really simple thing that we needed to fix, which is for every terminal in the grammar, we need to make a new variable, which I call u sub a, which only makes that terminal. And what we do is we strategically replace all the little a's as long as they're not just that one terminal, but in either with multiple terminals or with a mix of variables or something, not just that one terminal, then we replace it. So here I'm going to replace it with u sub a. This one right here gets u sub a. These b's right here are not going to get replaced. So then this one gets replaced. This one gets replaced. Oh, this is going to be quite cramped. Okay, so then now we see 3 b's in a row, and then those ones we do replace. As long as it's not just the single terminal, then we can replace it. So u sub b, u sub b, u sub b. The multiple variables are okay, we're not going to deal with those. The 3 b's here, of course, are going to get replaced. And finally, these ones, other than this b, so this a is going to get replaced. So u sub a. And of course, the other a right here is going to get replaced. And this is the point where all my students will tell me where I actually messed up and which ones I forgot about. But I think I got all of them. So all of these are good. These are good. The b's are not going to get replaced. These ones are okay. I replaced them. These are all good. And these have one terminal. Great. So now the only thing we need to do is to deal with these long right-hand sides that have a bunch of variables in them. And they can't have terminals because we just fixed them. So let's deal with that. So for step 5 in orange, we're going to break up, so this is just my term, break up long right-hand sides. And what I'm going to do, just like before, I'm going to copy this grammar down, copy down to here. Okay, so here's how we're going to do this. So any rule that has exactly 2 variables, we don't touch. We're not going to modify them. But for the ones that have 3 or more, we're going to take the first 2 and we're going to make a brand new variable I'm going to call y1. So y1 is going to make these 2 first variables right here. So a and u sub a. And I'm going to replace that with y1. So y1 is going to make, oh, what did I have? I just forgot it. a u sub a. Sometimes I forget what I wrote. But yeah, this y1 replaces that a u sub a. So if I wanted to apply this rule, the only thing I can do is y1 makes those 2 variables, and so therefore we would recreate the original rule that was there. But now this has 2 variables, this one has 2 variables. Okay, so technically what you should do here is to make a brand new variable like y2 that makes a u sub a, but we see that it's already over here. So as long as we don't add an additional rule for y1 and just use this one only, but repeatedly use y1, then it's still correct. It's just a little harder to actually prove that it's correct, but it actually does work. So I should make a y2 here to make a u sub a, but I'm just going to reuse the same variable purely for our sanity and for space reasons. Okay, so this rule is the same. This one doesn't need modifying. This one doesn't need modifying. We get a u sub a down here. So that's going to be y1 again. This one doesn't need modifying. This one does, and I can't have u sub b, which is another rule for y1. I gotta make another variable. That one I actually have to do. So I'm gonna have it be replacing the first 2 variables here, right here. So then I'm going to remove them, and this is gonna be y2. This one, so these 2 rules on the end I don't need to modify, but this one I do, and so I do need another variable because I haven't done one for AS yet. So I'm going to have Y3, which makes AS. So AS is going to get replaced with Y3. So now we get down to this one. The 2 u sub b's was Y2 before. The AS was Y3. The AS and SA don't need to be modified. The AU sub A we already did, that was Y1. And this one doesn't need modifying, this one doesn't need modifying, and these two obviously are okay. So that was an entire conversion of a relatively simple grammar into Chomsky Normal Form using these 5 steps. What I actually recommend you try in the comments is to work with this grammar and try to do the steps in a different order. I actually don't know if it still would work, but it's a good exercise to actually understand, does it actually still work? Or if I did step 5 first, would I reintroduce a unit rule, for example? And that would be actually really interesting to know. So hopefully that was interesting. Leave your thoughts down into the comments, as well as liking and subscribing to the channel. It really helps us out. There are many other links in the video description, such as our Discord server, Patreon, and other links if you want to further support the channel. And as always, I'll see you next time.